Okay, welcome back. Let's do another example here. So in this case, now we've got this one, and we want to estimate, we want to calculate the partial sum of S5, right? So that's going to be equal to 1 over 1 to the 5th plus 1 over 2 to the 5th plus 1 over 3 to the 5th plus 1 over 4 to the 5th plus 1 over 5 to the 5th. And again, you can use your calculator and approximate this, right? And if we do, what do we get? Oh, we get 1 plus hold on one. Hold on 1 second. Okay, so I got 1 plus 1 over 3 to the 5th plus 1 divided by 4 to the 5th plus 1 divided by 5 to the 5th, and I get 1.03666. Okay, so there's my approximation of S5, S sub 5. So now let's do the remainder. So this time I'm going to find the formula and then just stick in the number, right? So let's say we know that R sub n is going to be less than, right? It's going to be less than what? The integral from n to infinity of 1 over x to the 4th dx, right? And so this is going to equal the limit as t approaches infinity of the integral from n to t of 1 over x to the 4th dx, which is going to equal the limit as t approaches infinity of what? Okay, well, this is going to give us negative what? 1 over 3x to the 3rd. Okay, and we're going to evaluate this from n to t. And again, so some of you may already know where this is going to head to. So this is going to be the limit as t approaches infinity of the negative, and it's going to be what? It's going to be 1 over 3t cubed minus 1 over 3 capital N cubed, right? And of course, this is going to be the limit as t approaches infinity of 1 over 3n cubed minus 1 over 3t cubed. Okay, so again, using the properties of limits, this doesn't have any t's in there, so this is just a constant, and this does have t's in there, so we can use the limit on this one. So it'll become this minus the limit of this as t approaches infinity. Well, obviously this is going to 0, so the limit of this thing goes to 1 over 3n cubed. All right, so now that means our r sub 5 then, our remainder, r sub 5, has to be less than what? Less than 1 over 3 times 5 to the third. Oh, wait a minute, I messed up. Ah, gosh darn it. It's not to the 5th, it's to the 4th. I don't know why. This is to the 4th. Okay. I mean, that doesn't change anything other than just my estimate for S5. Okay, let's try that again. So, okay, so that's going to be 1 plus oops, and then okay. Okay, so it just changes a little bit. Okay, sorry about that. So it should be the 4th. I put 5s up here only because I think I just got tunnel vision and saw 5 there and just, I don't know, I had a brain fart. Okay, so this is S5. Excuse me, S5 is this. Okay, but all the rest of this is right. So obviously you can see that it's correct. So now, what do we get here? So this is equal to 1 over 375. And so, what do we get? We get 0.0026. Repeating. So it equals 2.0. Hold on a second, let me look at that again. Okay. So we know that error is less than that. Okay. And again, what if I wanted the error to be less than 0.001? Well, I can use the same thing I did before. What if I wanted, so we're pretty darn close to this, right? So this is the error. Okay, so here's our estimate, right, of S5, so this is our estimate, and this is the remainder is off, we're off by the true value of this by this much, okay? And what if I said, well, what n value, how far do I need to estimate, right, S? What does my capital N have to be in order to be within 0.001? Okay, well, I want R sub n Well, we know r sub n is going to be less than 1 over 3n cubed, right? And we want this to be less than what? 0.001, again. So now I'm just going to solve this inequality. So again, this is equal to 1 over 1,000, right? Just to make things easier to work with. And then I'm going to just take the reciprocal of both sides. And if I do that, I have to flip the inequality. So that means I got 3n cubed is greater than 1,000. And then if I divide both sides by 3, I get n cubed is greater than what? Okay, so let's say now I need to take the cube root of both sides. Okay, and so here's what I'm going to do, because I don't have my calculator with me. I get 333.3 repeating, so we'll just 0.33. And then I'm going to take the cube root of both sides, so I know n has to be bigger than the cube root of 333, right? And so this you can just get in your calculator, and once you put this in your calculator, whatever decimal you get, you want to round up to the next integer, and then that's going to be your n value. Okay, so that's where I'm going to leave it. I'll let the rest for you. Have a great day.